Okay. So you know about focal length, right?
Yes, sir.
What is focal length? Can you tell me? What is focal length of a mirror?
Sir, it is the distance or the center of a lens.
Okay. It is a distance, or you can say, yes, we are talking about focal length. So it is a distance from a mirror at which the
Our eyes see.
rays coming from infinite distance converge.
Okay, sir.
Okay. So any object
Explain it
which is
again.
so any object which is at infinity focuses at focal point. So if we talk about this point, it is focal point.
So where two rays intersect.
Yes, I will repeat it. And this distance, the distance from the, what we say this point, the pole.
Focal length.
Yes, sir. So,
Okay. So distance between this point, focal point, and the pole of
Focal
mirror,
length.
this is focal length.
yes, sir.
Okay. So the focal length, it is the distance between pole and the focal point. Okay. And all the rays which are coming from infinity. So these rays are coming from infinity. What do you mean by infinity? That at a very large distance. Infinity. So whenever you say infinity, that means the rays are coming from very large distance. Rays are
Okay, sir.
coming from
So what is
very
pole and focal point?
large distance. Okay, ask again.
So what is pole and focal point?
Okay, pole is the center point of mirror. Okay, right now I have made one mirror. Can you tell me what kind of mirror is this?
So concave.
Yes, it is a concave mirror. Right. This is a
So
concave.
does this work for a plane mirror?
Uh, you are asking pole for a plane mirror.
Yes, sir.
Okay, plane mirror itself is flat. Okay, it
Yes.
itself is a flat. So you can measure any distance from any point. Okay, you can take this point, you can take this point, you can take this point, you can take this point. Okay, so you can take any point and you will get the same distance. Whereas when we talk about concave mirror and convex mirror, we always take distance from pole. Okay, so it is the outermost point. Okay,
So pole is not present in a plane mirror.
pole is not present yes, pole is present in a plane mirror. All of these are poles. You can say all of these are poles.
So
So
then
pole
why
is
do so
pole
so
is
we can keep a point anywhere in the concave mirror as well.
point anywhere in the concave mirror.
So like we can keep the pole anywhere in the concave mirror.
Sir,
Or is
but
there
it
a fixed
depends.
place?
It depends upon like at which direction of the concave mirror the uh, rays are hitting. Then we can find out the pole, right?
Center point. Just
Like
wait a minute.
Sir, I
So you're
understand.
asking me that if we can put any point in the mirror and it will act as a pole, right?
Yes, sir.
Okay. So the sign convention of the concave and convex mirror work like this. First, let me tell you about the plane mirror. So let's say you are having a plane mirror like this. Okay. So whenever you make the diagram representation or the ray representation, you always break this mirror into two half. Okay. So the line which is breaking this into two halves, and
The
the
normal,
point which
normal.
okay, the point which intersect the intersection point of these two, the mirror and this line, this we will say as pole. Likewise, if we make a concave mirror or a convex mirror, what we do, we always make a line which separate the mirror into two halves. Okay, so we always make a line which breaks the mirror into two halves, and we always see, okay, that there is a focal point on this line, there is a center curvature of on this line, and there is a pole on this line. So our sign convention on the mirror, this concave and convex mirror, always written in respect to this line. Okay, this line. So our sign convention and the everything we write always work on this line. And why we are taking this line? Because let's say if a ray is coming from up and a ray is coming from down, okay, these ray will always focus on this focal point. Okay, the line which breaks the mirror into two parts and the point on it. Okay, that's why we always take this line, and we always represent the point, the intersection point of this line and mirror as pole, this point as focal length, and this point as center of curvature. Got it? So
Yes.
we cannot say that if you take a point on here, if we cannot take this point as a pole, the pole always lie on this line which I have made, dotted line. Okay,
Yes, sir.
apart from that, if I've asked you, is the distance between, wait, let me rub it. If I ask you, is this distance, this distance is the, can you tell me if these distances are equal or not?
No, sir.
No, why?
So they're different.
They are not different, they are all same. Okay, so whenever we
Sir,
make,
because if we draw a big circle, sir, and center of curvature is taken as a center, then all of these are radii and radii of our same length.
correct, so like there is a circle, if we make a circle, in circle we have a center. Okay, this is center. Okay, so how we make this mirror, we take some part of this. If this is a whole mirror, we take this part, okay, and we coat it. If we coat it outside, then it is a concave mirror, and if we coat it inside, if we coat it,
Inside, then it's a convex mirror.
yes, if we coat it inside, then it is a convex mirror. Okay, likewise the center, why we are saying it's center of curvature? Because it acts as a center. If we take the this, if we complete this mirror, the mirror which I have made, if we complete this, okay, if we complete this like that, then this C will act as the center of this whole complete figure. Okay, so the distance from this C to any part, okay, like in the circle, if we take any distance, this distance or this distance or this distance, okay, so these all distances are same in
Same.
circle because these are radius.
Radius.
Likewise, this also is a kind of a radius, and we take it as R.
So,
Okay,
so
got
what
it?
will change if we change the pole's position?
What will change if we change the pole's position? Nothing will change. Like if you say this is a pole, then the mirror should be here.
Yes, sir.
Okay.
Like on the mirror only if we change the position.
Like you can take any part of this mirror. Okay, I got it. You want to ask that if we can make this ray like this. Okay, if I make a mirror and I make a ray like this, are you asking this?
Yes, sir.
But that way we cannot divide this whole mirror as in two parts. Okay, two equal parts. Can you divide it?
No, sir.
No.
Sir,
Okay,
so the
so we
pole should divide the mirror into
ha
two parts.
two parts. Yes, correct. Okay. Any other doubts? Okay, Rohit was asking this. Okay, fine. I was telling that infinity is any distance. Okay, if I'm saying that the rays are coming from infinity, that means these rays are coming from a very large distance. You, I think it is clear that what is focal point and focal length. Any doubt? No doubt?
No doubt, sir.
Okay. So these are, now I'm telling some new rules for the class. No interruption between if I'm explaining something. Okay. After I explain it, then I will ask you that if you have any doubt. Okay. If I'm explaining something like I am explaining mirror, so you can ask the questions related to what I am explaining, not some new concept. Like if I'm saying that I'm talking about red color, so don't talk about blue color. Okay, you can ask everything about red color. If you have what I'm saying, that regarding the curiosity questions, you ask after I say that if you have any doubt. Okay, that way our class won't be disturbed. Rohit, are you clear with the focal length and focal point?
Yes, sir.
Okay, so in concave and convex mirror, we always represent the power of lens, not mirror but lens. Okay, you got about focal length and focal point in mirror. Likewise, if we draw a lens also have a focal point, right? Say yes or no.
Yes,
Yes.
sir.
Yes, sir.
So what is the significance of focal point here? Yes, can you tell me, anyone?
Sir, can you tell again?
I'm asking what is the significance of focal point in lens?
Sir, like the point where all the rays from infinity converge at at this point, sir.
Okay, correct. So it is the same work as that of mirror. Like I told you in mirror, that if any rays are coming from infinity, those will converge at the focal point. Likewise, here also, if rays are coming from infinity, they will converge at this focal point. Okay. So when we talk about lens, we say that the power of lens is always equal to 1 upon f. Okay. Can you tell me what is f here?
Focal point.
Focal length. You cannot represent distance. Okay, I have represented this point as f, but this is actually length. How we write focal length?
Length from the pole to focal point.
Pole to focal point. Okay, here also we are taking this middle point as pole. So we always represent focal length as f. You can take any notation else also. So here f is stands for focal length. Okay, and we take this as bracket. I will explain why I have written m in the bracket. first tell me, are you clear that the power of lens is always equal to 1 upon f? Is this formula clear to you?
Yes, sir.
Yes, sir.
Okay, tell me, have you seen this formula before?
No,
No,
sir.
sir.
Sir, what
No.
is M?
So can you explain
That
once again?
okay, once again. So in lens, likewise in mirror, lens also has focal point and focal length. Okay, so the length, focal length, let's say the focal length in lens is f. So the power of lens is equal to 1 upon f.
Why,
Okay,
sir?
so what does that mean? That if I say the focal length is 100 centimeter, now I like see here. Okay, come to the point of m. So m stands for meter. M is meter. So whenever you want to apply this formula, you always have to convert focal length in meters. Then only you will get power in diopter. Power is always represented, power of lens is always represented as diopter. So let's say if you
So
have
what
a
is the
focal,
spelling? What is the spelling?
what is this?
Spelling of that.
DIOPR.
Okay.
I think it is this.
Okay, sir.
You can Google it. Okay, diopter. So the unit of power of lens is diopter. So I'm taking the focal length as 100 centimeter. Let's say focal length of a lens is 100 centimeter. Then the power of that lens will be 1 upon 1. Why I'm writing 1? Because I have converted this in meters. So it will be 1 diopter. Okay.
Sir, but why there should be a 1 on the numerator?
So it is a formula. Formula works like this. We cannot ask that why, because okay, like let me tell you.
It is inversely proportional.
That is the same language. Who asked me this question?
Someone has
Sir, so greater the
Manasvi.
power of the length, then less the focal length.
Okay, Manasvi. Can you tell me any formula you have been using until now? Any formula, as very simple will work also. No?
so like we
Okay.
use many for area and
Okay, area. Okay, tell me area. Fine.
so like
Okay.
power is W by T.
Power is W by T. Okay. With this formula, I want to be able to explain, but let me take my formula. Velocity.
Sir, maybe frequency and time period.
Hit and trial method. Have you seen this formula? V equal to U plus AT.
Yes, sir.
You have seen? Okay, very good. So this is a Newton's
Law.
formula. Okay. So can you imagine, can you tell me how this formula came? What is the reason that the Newton has written this as V equal to U plus AT? Why V equal to U plus A by T? Okay. Why V equal to U by A plus T? Like this. Can you tell?
No, sir.
No. So what he did, he took some values. he took some values as u. Let's say he took one value as u, one value as a, and one value as t. Okay, and did this experiment physically. Let's say if he is using a car, he initially what he did, he took some initial velocity. Okay, if others who do not know this formula, let me tell you. Here v stands for final velocity, u stands
Sir,
for
what is
initial
final
velocity.
velocity?
I will tell you. A stands for acceleration and t stands for time.
Time.
So you will encounter this formula again and again in like every part of your studies. Okay, whenever there is physics, you will encounter this formula, the Newton's formula. So what does that mean? That let's say you are cycling, or let's say you are driving a car. So you are driving a car. This is your car. You have some initial velocity. Let's say initially you are driving at 10 meter per second. Are you with me until now?
Yes.
Okay,
Yes, sir.
good. So you are driving with 10 meter per second. So what is this 10 meters per second? This is u,
U.
initial velocity. Very good. Now I accelerate
Sir, so
this
the initial velocity means like the velocity or speed that is
starting.
Velocity.
that is used to move the car from like a stationary position to like to move, right, sir?
I'm not taking this as stationary. I'm assuming that this has been at 10 meter per second from the start. Okay.
Okay, sir.
Okay. So the starting speed of this car is 10 meter per second. Got it? Now what I'm doing, I'm accelerating this car. I'm accelerating this car at, do you know by acceleration how you increase
Yes, sir.
acceleration in a car?
By
Meters per
applying
second
more
square.
force.
Applying more force. Or if you have seen your parents driving car, what they do actually to increase the
They
acceleration
step
or
on the accelerator.
accelerator. Very good. So let's say I'm Manasvi is driving this car and she stepped on the accelerator. So she is accelerating this car by 2 meter per second square. Okay, this is the value of the amount by which she is accelerating that car. And she has accelerated, she has put her foot on the accelerator for 10 seconds. Are you with me until now? I
Yes.
have taken the
Yes, sir.
initial velocity. I have taken the initial velocity. Then what Manasvi did, she stepped on the accelerator for 10 seconds and increased the acceleration by 2 meter per second square. Okay. And then after 10 seconds, what she found out, that the final velocity, okay, the v here, v is the
Calculate.
final velocity. Okay, so instead of calculating, you can directly see at the meter. Okay, the speed meter in your car, you can directly see that it shows what, 20 or 30 meter per second. Okay, it give you 30 meter per second. Likewise, you use this formula and you put values in this formula. Okay, if you put your values in this formula, v equal to
Sir, can you
u
scroll
plus
up once?
v equal to u plus 80, and you put u as 10, a as 2, t as 10, and you get 30 meter per second. So this is the way how one verify any formula. He again and again do some experiment and then see that if these values are fitted in this formula, those are correct or not. Okay, this is how any formula is generated. If you come up with like you do experiments in your 11th class, 12th class, or in your graduation, what you will do, your teacher will give you one formula, that let's say he is giving you a formula t equal to 2 pi root L by G. Okay, don't ask about what is this formula, just it is a formula. So what the teacher will do, he will give you this formula and he will say that you do take different values of L. Okay, G is constant. Don't ask me what is G, but G is constant.
Gravity.
So gravity, correct. So he will tell you that take different values of L and tell me what will be the time period, and verify that with the help of formula also. So how I will do this experiment? I will take a different length and I will, like, this formula is of pendulum, swinging pendulum. Okay, so how I will perform this experiment? I will take a stopwatch. Okay, I will take a stopwatch and I will take a length. Let's say I have taken length as 10 centimeter. What is this length? Length is the length of the string. Okay, this is the pendulum, this is the ceiling, this is rope, this is pendulum. Okay, so
Sir,
you guys are aware about pendulum. What the pendulum do? Tell me.
sir, it does
Sir, it,
oscillation, sir.
sir,
It
it moves
it
in a to and fro motion.
to and
Flow
fro
motion.
motion. Very good, very good. It do to and you guys are well aware about this. I was like thinking that you won't be able to get it, but you guys are aware that what is oscillation. So this pendulum is doing oscillation, and I think you get it what the T here means. Can you tell me?
Time period.
Time
Time
period.
period.
Very good, very good, very good. So this is the time period.
Sir, what is like gravity? Is it like 11 meters per second?
No, so
It
it's
is
9.8, right?
9.8 meter per second square. Okay, fine. So in higher classes, you will be told that this is the formula to calculate the time period of a pendulum. Here T stands for time period, 2 pi is constant, root L by G. L is the length of the rope, G is the gravitational constant, 9.8 meter per second square. So they will say that you need to verify this formula using experiments and the theoretically. So what I will do, I will take a length of the rope as 10 centimeter and I will force this pendulum to oscillate. So what I will do, I will start the stopwatch. Okay, so what does time period mean? Wait,
So the
do not
time
answer,
taken
do
to
not answer.
complete.
Wait. Okay, let me ask Harshit, can you tell me what is time period?
So 1 second.
Okay.
So I can just repeat the values.
I'm not asking about, I'm not asking to calculate it. I'm asking what is time period? What is time period in respect to oscillations? What time period give us? We have seen this time period in sound also. Okay, in sound also we discussed about time period, that what is the significance of time period, what time period give us. Do you remember, Harshit?
Yes, sir.
Uh, okay, yes, then tell me. It's okay if you don't remember, we will see it. Just tell me if you know, yes or no.
So not getting.
No. Jitendra, wait. You need to maintain the discipline. Like if I'm asking about a student, then I need to know that answer from him, not from you. Okay, I will come to you. No, then Sheshta, do you know what is time period?
Sir, it is the number of like, no, the time taken for one oscillation.
Okay, time taken for one oscillation. Very good. So what does that mean? What is one oscillation? That if I'm oscillating this pendulum, so if it is in this position, it will go here,
Sir, it's
then
to
it will
or to and fro.
to and fro, one complete oscillation. So the time, let me write it. So what is time period? It is the time taken.
by a pendulum to complete one full oscillation.
Yes, you can write by a pendulum to complete one complete. Complete will be repeated. To do
One full oscillation.
one
Complete
complete
one full oscillation.
oscillation. Okay, so that is the time taken by the pendulum to complete one oscillation. Okay, one full oscillation, like Karthik is saying, one full oscillation. Okay, so this is what time period is. Harshit, is it clear to you?
Yes, sir.
Okay, Harshit, it is your homework that you have to revise sound again, and I will ask questions to you about sound in next class. Okay,
Okay, sir.
is it okay? Okay, very good. So one homework for Harshit. Is this spelling correct?
Yes, sir. So it is H. The HR is HRA.
SHITH. Okay, sorry. Harshit, to revise sound. So that way I will remember too. Fine. So you know about time period. So in higher classes, you will be given this formula that T equal to 2 pi root L by G. Using this, you have to calculate. So now what I will do, I will go, I will grab this pendulum and I will pull it to some distance. I mean, I will leave it. Then I will start the stopwatch and I will see that what will be the time taken by this pendulum to complete this one oscillation. And when this pendulum completes one oscillation, I stop that stopwatch. Okay, and I record this time in my notebook. I do this experiment 20 times, 30 times, and I record all these values. Okay, now, okay, and these are I'm doing for only one length. Now I will change the length and I will do this experiment again, and I will record all these values. Now I will put these values in this formula. Okay, what formula? This formula. T equal to 2 pi
equal to
root
2 pi root
L by J. And I will see that what is the value we get from this formula, the theoretical value. And I will check if the values I am getting experimentally is same as that of this or not. Okay, so this
Sir?
is how. Yes.
So what if the square root is not a perfect square? How do we calculate it?
How do we calculate? Can you tell me what is root of 2?
Sir, we have
It comes in
That is
decimal.
1.16
So it's irrational.
414 something.
1.14.
Okay, so we do this thing by calculator. We cannot, we can calculate. Okay, in mathematics you must have learned in your 7th class or 8th class also that how you calculate square root of any value. But for in higher classes, for easy calculation, we always take calculator and we do this calculation. Like if you get root of 50, you directly do with the help of calculator. So you will get this value. Is it okay?
Yes.
So I will try to match that if I get theoretical value as experimental value or not. So this is how the scientists got to arrive at this formula. Okay, so they did some hit and trial. They did some hit and trial. They tried to fix these values. They tried to manipulate these formulas, and then they came up with this perfect formula. This perfect formula in which we put value and we get the exact value. Okay, if I do this experiment, I will get almost similar value. Okay, if I get let's say if I'm getting the time period as 2.01 second in experiment, okay, while doing experiment, I will get t equal to 2 second from theoretical value. Okay, almost same. Why there is variation? Because we are humans. Okay, we do some error while, like, let's say if I
Manual
have
error.
the, yes, human errors, we put this as human error. Okay, but this is how these formulas are generated. The scientists have they done some hit and trial, and then they came up with this formula. So likewise, we say that the power of lens is 1 by f. This is also done with the help of the error and calculations by the scientists. Okay,
So normally time period of like
no, not going to time period. We came back to power of the lens. I remember this your doubt, Jitendra or Ashwath. Okay, Ashwath, remember this doubt, and I will ask you after I complete this topic. Okay.
yes sir.
Okay. Are you guys clear with the doubt that how power of lines can be written as 1 by f? Like it is not in your hand. It is, this is formula, and the formula works like this. Okay.
Yes sir.
Okay. So we calculate the power of lens with the help of this. So you must have seen that lenses you come like the people who the students among you, you are wearing lenses. Okay, so the glasses. So you must have heard, or you must have known that these glasses have some value. Can you tell me
It's
what
like
is the,
0.25.
Power.
yes, the power? Okay, can you tell me what power you are wearing, Ashwath?
Sir, 1.75.
Minus 1.75. Okay, so this is the value of power which we represent in diopter. So while speaking, you never uh, pay attention to that unit. You say that the power of lens is 1.75, but actually it comes with the unit diopter, d. You always say power as 1.75 d. Okay, so this is how the power of lens comes from the focal length. Is your doubt clear, Rohit?
Yes,
Rohit, are
sir.
you there?
Yes, sir.
Okay, can you repeat what was your doubt?
So the question, right?
Your
Sir, it
question, yes.
was what is the accommodation of power in our eyes?
Yes, accommodation of power. So you do this formula 1 by 0.25. Okay, you
Okay, sir.
know the least distance, f least is 25 centimeter, right? Which
Yes, sir.
which can be written as 0.25 meter.
Okay, sir.
And when you use this formula, what you get? 4 diopter.
Sir, how are you getting 4?
By dividing.
Use
Like it's 1/4, right? Or no, it's not 1/4. It's 1 by something. It's not like it doesn't.
okay. So I have like made a square on this formula. Remember this formula? So whenever you want to calculate the power of lens, you put focal length and you will get the power of lens. Okay, got it, Ashwath?
Yes,
How
sir.
here 4D came. Okay,
Okay, sir.
so this is how we calculate power. So any doubt? Final doubt? This was our some extra question which Rohit wanted to ask, that how power is calculated. So we are done with this. Any doubt related to this?
Sir, why did you take only 0.25?
What I told you, how which unit is used in this place?
Sir, like, why
What I
only
told you,
0.25?
focal length, how,
So,
which, Mhm. Yes, Manasvi.
so when we wear the specs, what is the focal length over there?
What is the focal length over there? The focal length is decided in the specs. Okay, like let's say if the specs are decided as 200 centimeter, or forget it. Can you tell me anyone you related to you who is wearing specs and the value of the power of their specs?
So like
Sir,
0.25 is the power.
0.25 is a power. 0.25. We know the formula as P equal to 1 by F in meters. So I will substitute this 0.25 in place of P
And then
in
we'll
1 by F.
transpose
1.0.25, and we get what? 100 upon 25, and this as 4.
4. So
So
focal
4
length is 4. 4 meter.
meter. 4 meter. It is actually 400 centimeter.
So
Okay.
how will the distance be 400 meters? 4
How will be the
meters.
4 meter.
So
How can it?
where is that distance actually? From our eye to spectacles?
Okay, I told you that we need specific focal length.
So where does the focal length lie over there?
Why does the focal length lie over there?
So because the lens is the lens in the specs, right?
Mhm.
So where is the focal length? Is it our
Okay,
eye?
okay, okay. Okay, where is the focal length? Okay, okay,
So
fine.
where is the focal point?
Okay, 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 okay. Wait. So you must have seen that the specs are either in this shape or in this shape,
Yes, concave and convex lenses.
concave and convex lenses, correct? Okay, so the focal length is associated with this only. If I complete this whole length, the focal point will be here, 400 centimeter.
So is it
Okay,
away from the spectacles?
it is away from the spectacle. Yes.
So the point from where we see.
Correct. No.
The
See,
farthest point we
see
can
why
see.
see why we wear these spectacles. Let's say let's say this is your eye. Okay, this is your eye, and what happen? You cannot see the near objects. Okay, you cannot see near objects. Let's say here is some pen. Here is some pen, and you cannot see. So what is the reason why you cannot see this pen? Because there your the lens which is attached to ciliary muscle. Okay, which muscles are responsible for stretching and contracting the lens? I'm asking, which muscles are responsible for contracting and stretching the lens?
Retina.
Sir, ciliary muscles.
Ciliary muscle. Very good. Who spoke? Who spoke?
Sir, Jitendra.
Jitendra. Okay, Jitendra. Fine. So ciliary muscles are responsible to stretch this lens or contract this lens. Now you are not able to see this pen clearly. Why? Because the ciliary muscle must have grown weaker. So these ciliary muscles are not working properly, and it cannot focus this pen towards your retina. Okay, so that means the ray coming from this pen, let's say the ray coming from this pen, these are going like this. Okay, what does that mean? That these are not converging at the retina. Okay, the outer part, the back part, this part is your retina. In order to make an image on retina, the rays should converge at the this surface, this retina. But because these ciliary muscle must have grown weaker, so these cannot make the uh, required adjustment of these lens, due to which the rays which are coming from this pen cannot be converged at the retina. Instead, these rays are going behind the retina. Okay, these are not converging, but these are going far. So that way you won't be able to see. But if I include one lens, let's say I have include one convex lens. Okay, the spectacles, the specs you wear, I include this specs. So what this specs will do? This spec will converge this ray. Okay, this spec will converge this ray, and this spec will converge this ray also, so that it merge at retina.
So where is the focal point in this?
So where is the focal point if I complete this?
So on the
So
retina.
yes, on the retina, correct. So the focal point of this lens is on the retina. That's why these rays are converging at retina. Okay, so the doctors use this method to make a suitable lens, the suitable spec, so that the light can be focused at retina. Got it?
Yes.
Okay, anyone else? Any doubt? Any of your curiosity doubt? No? Okay, let's start with the paper discussion then. Wait. We are running how much? 50 minutes behind. Okay, the first question. Wait. Okay, can you see this question paper?
Yes,
Hi,
sir.
hello. Okay.
Yes, sir.
Tell me first question, the answer to the first question. What is light and how
Sir,
does it
light is a
travel?
form of energy and it doesn't
It
require
travels
a
Travels in a
medium
straight
to
line.
travel, as it is as it is a radioactive, like not radioactive, electromagnetic
So can we write that
wave.
it travels in a straight line?
Okay, very good.
Light
It
is a
travels
form
in
of
a
energy
straight
and
line.
it travels in a straight line.
Very good.
Sir,
This answer is
sir,
perfect.
I wrote it like light is a form of energy. It
Mhm.
doesn't require a medium to travel, as it is a electromagnetic wave. It always travels in a straight line.
Very
But
good. You can write that also.
it can change direction when it gets refracted in water or other material.
No need for these explanation. The earlier one was sufficient. Venetia, the answer told by Venetia is more than sufficient to answer this question. Now, anyone has any doubt in this question? Just say yes and no, and we will move forward.
No.
No, sir.
No, sir.
Okay. Second question. Name the parts of a human eye. Let's start from the outermost.
Sir, cornea,
Sclera.
iris,
Sclera. Sclera.
Cornea.
Sclera.
Okay. Tell me where you have heard this sclera.
Sir,
I
it's
think
the
this
white
name is
part of the
not
eye.
in the this name is not in the NCRT, if I am correct.
Sir, but it's there in the notes. Like you gave one day, right?
Okay.
Yes, sir.
Fine.
sir,
Okay.
cornea,
Sclera.
iris, pupil,
Mhm.
retina, rod cell, cone cell, optic nerve, blind spot, aqueous humor, and vitreous humor.
Okay.
Sir,
Very good.
and there's also chloride mentioned in our textbook.
Chloride? No.
Sir, sclera, cornea, iris, pupil, ciliary muscles,
Yes, the
uh,
ciliary muscles too.
ciliary
Optic
muscles,
nerves.
retina, blind spot, aqueous humor, and optic nerve. Rods and cones also. Rods and cones.
Okay, that's very good. You remember all these. That is very good for you that you all know all of these. And but for exam perspective, you need to know these main only. Okay, sclera, very good. No problem in that. But
Cornea, iris, pupil, retina.
let me show you. Can you see this image? Can you see this image?
Yes, sir.
Yes, sir.
Image of an eye. So these are the main parts you need to know. Okay, and if you write sclera, it will provide a good impression in your teacher that you know this much. Okay, it is very good impression on your teacher. The outermost part is cornea. Then comes iris. After iris, there is pupil. Pupil is not written here, but you should know pupil. Pupil is important part of eye. After iris comes pupil. Then pupil, after pupil is lens. The lens is contracted and stretched with the help of ciliary muscle. And then comes retina. And all of the signals which are falling on retina are sent to the brain with the help of optic nerve. Okay, so these all you should know. Any doubt?
No, sir.
Very good.
No, sir.
Now next question. Uh, how many types of reflection are there? Name them.
There are three types of reflection: diffuse, regular, and multiple.
No, there are only two types of
Two
reflection.
types.
Sir,
Diffuse
but
and
in
regular.
the textbook there are three
Let
types. There's also multiple.
which textbook?
Sir, I have focus science.
Which book?
Sir, the Falcon series, focus science, class 8.
Okay, I don't know about that. I know about NCRT only.
Sir,
So according,
actually our school till 10th does not follow NCRT, so
they does not follow NCRT. How?
no, sir, only till 10th in CBSE.
I didn't knew that. Like I have been to the CBSE school and they follow these NCRTs starting from class second and fifth
Sir, they actually
whenever they.
changed it a bit after COVID, so
Okay. So according to your book, there are three types of reflection.
yes, sir, they also mentioned multiple for
Sir,
some.
multiple
Okay.
reflections are like
Let
multiple
me
images.
let me tell you why I'm not saying multiple reflection among these type of reflection, because multiple reflection is also due to the regular reflection. Okay, how multiple reflection occur?
When
Let
there
me
are
share.
more than one plane mirrors.
Yes,
Like because of plane regular reflection on plane mirror, multiple reflections happen.
Sir, I understood why my marks went in the test.
no, I haven't deducted your marks due to this.
Yes, sir.
Okay, but if it is written in your textbook, then you should like write it as three types of reflection, and those guys who have NCRT, you should write the regular and diffuse only. Why I'm saying the multiple reflection not as a type of reflection, because this multiple reflection is formed. I was showing you how. Wait. Okay. So what is regular reflection? That if a ray is coming like this, it will go like this. Okay. These are parallel. Okay. These are parallel. Don't take it as diffused. And what happen in multiple reflection? Let's say if you are taking kaleidoscope. Kaleidoscope, instead of kaleidoscope, you can take one instrument used in submarines. Can you tell me the name?
Periscope.
The mirror at the top.
So that's periscope.
Yes, periscope. Correct. Periscope. So how periscope is there? You must have seen this in movies. Okay, what happen is, if this is submarine,
Slanting mirrors.
if this is submarine and this submarine is inside water. So what one person will do? He will open this periscope. Are you sure the name is periscope only?
Yes, sir.
Yes, sir, it is periscope.
Sir, isn't it a kaleidoscope?
Kaleidoscope is different. Kaleidoscope is used to make different type of patterns. Okay, you like I have shown you that in kaleidoscope it is a tube with 3 mirrors inclined in a triangular shape, and if we speak from the hole in the kaleidoscope, we see different types of colorful pattern, right? So kaleidoscope is only to see the different kind of pattern formed due to the small colorful glasses. But what periscope is? So how Navy personnel use? So this is submarine. This submarine is like traveling inside this water. So one cannot see what is happening at the surface. So what they will do? They will take out one kaleidoscope which has a small section here and a small
Sir,
section
it will
here.
have a slanting mirror at
Slanting
each,
mirrors.
and then on the
Yes.
top also it will have a slanting mirror, so they can
Correct.
actually the light going through the tunnel or this part, it actually reflects, and then it can come to our eye.
And let's say
So the slant of the mirror is 45 degrees in total, which makes 90 degrees straight.
correct. So let's say Ashwat is swimming on the surface. Here is Ashwat. He is swimming on the surface, and this submarine is inside the water, so it cannot see what is on the surface. So in order to see, like let's say Rohit is driving this submarine, what he will do? He will open his periscope and he will see that the light which is coming from Ashwat will enter. There is one mirror at here. Okay, one mirror there in this section. So what will happen? This light will fall on this mirror and it will be reflected inside. There is one more mirror at this part. So light will again fall at this part and it will go here. Okay, this is the path of the light, and it will go if Rohit is standing here, and it will go into the eyes of the Rohit. So this is how periscope works. This is the periscope. And the kaleidoscope is completely different. It is used to see different kind of patterns, whereas periscope is actually kind of a vision instrument. It is a vision instrument used by Navy personnel to see what is happening outside or at the surface. Okay, so search some videos on YouTube, you will find it, that how this is used. So which part I was? Can you tell me why I came up with on this periscope part? Okay, I came up with this on this periscope part because I wanted to tell you the multiple
Is it
reflections.
related to multiple reflection?
Correct. So this periscope is working on the principle of multiple reflection. How? It was reflected on this mirror. This is M1, and then it got reflected from M2. So it did reflection more than once. So we say this as multiple reflection, and it is following the same pattern as that of
Sir, multiple reflection means like maybe there are like two or more mirrors in like opposite to each other, or
Okay,
aligned with
you
each other in a way.
you yourself told me that 2 and more mirror. So any reflection, if there is any light coming and it is reflected more than once, it is
They're
reflected
aligned.
more than once,
They're aligned
then
with
it is
each
a
other in theta, and then
Yeah.
number of reflections is
correct.
360.
They
Yes, sir.
they can be parallel also. They can be parallel also. They can be aligned at some angle also. Does not matter. The thing that matter is this light gets reflected more than once. If gets reflected more than once, that means it is a phenomena of multiple reflection. So here also in periscope also the multiple reflection works, and which principle they are following? They are following the regular reflection. Okay, can you see that they are doing regular reflection? I equal to R. Okay, so why I didn't told you this multiple reflection as the type of reflection? Because it actually follows the principle of regular reflection. Okay, this angle of incidence is equal to angle of reflection. Okay, but if it is mentioned in your book, then please consider it and write it in your exam. Don't worry, I haven't deducted your marks on this on the basis of this. Let's move to the next question.
Time up.
Time is up, I know, uh, but in every class we are not able to move forward to our topic. Like we have to start the chemical effects of electric current, but we are not able to do it. Don't worry, in next class we will study that only.
Yes, sir.
No extra thing, nothing extra.
Okay, sir.
Okay, you know about this fourth question. Write the name of colors of sun rays.
Sir, it will be Vibgyor, right? Since,
Vibgyor.
sir, like when
Very
the
good.
sun comes in
7
contact,
colors of
again it
rainbow.
forms the 7 colors, right?
Very good, very good, very good. The light coming from sun is white light, and white
Okay.
light is always split into 7 colors. The Vibgyor.
Sir, but colors of the sun, red, yellow, and orange, like the primary.
That red, orange, and yellow. That is like keep this question to yourself, and when we get some time, I will tell you this phenomena. Like how in the morning we observe red color, the sun as reddish or orange, kind of orange color, and in the middle of the day we perceive it as yellow, and in the evening time we perceive it as
Sir,
red. So these are all the natural phenomena due to which there is the change of color, but in actually only one light is coming, which is white light. It is only the position of the sun due to which we observe this variation of color, which I will explain to you when we get some time. Okay.
sir, actually, sun rays, like only Vibgyor are not the only colors that are there, right, sir? Like because like the colors of sun rays are not only Vibgyor, right? Because in the rainbow, like there are, we can see violet, indigo, blue, green, yellow, orange, red. But like between these colors, sir, like there is like some gradient, like
So
thing, right,
tell
sir?
me if you have you done drawing in your class in your academics?
Yes, sir.
Okay, when you apply one color, let's say yellow, and you apply blue color above yellow, will you see the same those color, or you will see some different color?
Different colors, sir. RGB.
Different colors actually. So when two colors combine, a new color is formed. Okay, so I
Like when
think
they
this
overlap,
answers your
sir.
doubt.
Sir, in the
It will
rainbow,
overlap.
like the colors overlap, right, sir?
Correct, correct, correct. Okay, next question. How you should take care of your eyes? I think you all know this answer. Differentiate between regular and diffuse reflection. Tell me.
So what are the primary colors?
Sir, uh, in regular reflection, I is equal to R,
Correct.
and it follows all the laws. In diffused, it doesn't follow.
Mhm. Correct. In diffuse reflection, as a whole, you will see that I is not equal to R, but
And the surface
you
of
see
reflection is
Surface
rough.
is smooth and rough.
smooth and rough. Okay,
Sir,
so uh,
yeah. Sir, if the
yes,
incident rays are parallel, then in the regular reflection, the reflected rays will be
are
parallel,
also.
whereas in the
Mhm.
irregular reflection, the reflected rays would not be parallel and scattered in different directions.
Very good, very good, very good. So you can like you can consider this the response of Karthik, and this is the ideal answer for this question. Okay, you can say also that the diffuse reflection does not follow the laws of reflection. Okay, but
Yes, sir.
this is good. That the incident ray, if incident rays are parallel, then the reflected rays are also parallel in regular reflection. Whereas in diffuse reflection, the reflected rays won't be parallel. I think you know about Drell system.
Sir, can you
Verify the
It's the
laws.
system which is used by visually impaired people who cannot see.
Okay.
It consists of numbers and alphabets. When they and these visually impaired people who cannot see, they move their hands to understand the letter and the number.
Sir,
Okay.
what
Correct.
I
Correct.
agree with Rohit, sir, but what I wrote is I wrote more better. Like the most popular aid for visually challenged people is the Braille system. I wrote that it has
Mm-hmm.
63 dot patterns. Uh,
Mm-hmm.
each character, each dot system or dot like dot
Mm-hmm.
pattern represents a character or a letter or a
Mm-hmm.
word or symbol, sir. The
Mm-hmm.
dots are arranged in like vertical two vertical rows of 3 dots each, and these patterns when they're embossed on braille sheets, they help visually challenged to recognize words by touching, and then to make the dots easier to touch, the dots are raised higher.
Just a second. Just a second. Just a second. Sorry. Sorry. My voice, like my earphone got disconnected. Sorry. Sorry. Uh. Okay. I have heard you. Your. Can you guys hear me?
Yes, sir.
Okay. I heard your response, Ashwath. Very good. Uh. Now we discussed until question number 7, right? The eighth, you know very well. Verify the laws of reflection by an activity. The main question is now the ninth and 10th. So we will discuss this in the next class. Uh, think about these questions. These questions are almost similar. Just read the wording of these questions and then observe what is the difference.
There's an answer 60° for the second one.
Answer is 120 degree for the second one.
Because 60 plus 60 is 120.
Okay.
Okay, so the difference, the long strand confusion we were having from the starting. So this confusion will be cleared after this question, these two questions. We will give some time. on these two questions in the next class, and all our confusion will be cleared. Okay, some confusion is from my part that I haven't told you these questions very clearly, but next time I will explain it very clearly so that you won't have this doubt further at any time in the future. Okay, don't worry about it. We
So
will
then we start chemical effects after that.
Yes, we will start chemical effect after that. These are the will be the last question, the first question of the our class, and then we will start chemical effects, and we will try to do majority part of it so that in the next class you will get some questions from the that chapter. Okay, so regarding chemical effect, I have told some part of the chemical effect in the last class, the potential, current, resistance, and all the power also. So you guys must know these things, the circuit, okay, the current, the potential, the resistance. So you guys must be aware about this. We have done some part. Okay, so if all of you were not there in the last class, you check, like see that recorded lecture and then come in the next class. Okay, otherwise you won't be able to catch up. Fine.
Yes, sir.
Yes.
Okay, then bye bye, good night.
Thank you, sir.
Bye, sir.
Bye, sir. Good night.